All right. Okay, we can start at this moment. Yeah, so update on the drone hardware. So last week, or even this week, it was a frame with motors and the wires, and I will show actually. The wires are to the ESC, I'm not sure what you're seeing, and everything to power distribution board. Then we have IMU with magnetometer connected currently without the hot glue, but it can be now done because the configuration is proper. I need to check the motor's direction, and actually we'll check with logic analyzer and power with the battery, so X6S 6 serial 24 volts, and we will check the signal for the terminal. Okay, from the terminal, because there is as well radio on the bottom, so there is radio with, maybe I can bring it, so there is radio with satellite, so Spectrum radio with Spectrum terminal, so that's one what we will be using. And actually the order of connection is to connect power distribution board to the LiPo, because from there is a 12 volt output to ST-G431, because we are using also the debugger, so 12 volts goes there. We have 3 volts out to the IMU, and actually signals from radio to electronic speed controllers through the MCU. So let's just do quick tests. Okay. So firstly, where is yeah, okay. So to the thrust from the radio, we check the radio actually. So there is a wire to the logic analyzer, the simplest version. So we have common ground and one channel for thrust. I won't be checking currently the other channels, because we will see that in the firmware for drone, but we will check the signal for one channel. So for that, okay, let me open serial logic, logic analyzer software, logic 2 actually, yeah, logic 2. Okay, so this is the program, and actually, as I mentioned, firstly we need to connect the battery. Okay, so this is powered, and then we can connect our microcontroller Nucleo through the hub, USB hub with connected logic analyzer. So currently we can connect that safely to the computer. Oh, sorry. Oh, I have camera there. Okay, so I have one more USB. Okay, so it opens channels, but we use the first one, and actually, as you see, the radio is not connected, but also let's open because the firmware is loaded, but we can debug that as well. So the thrust is disconnected, and the code for remote control is in remote control in the GitHub in FC, so flight controller static library. So I think the code is there. because in this project I have everything common in the drone catalog. So remote control is there, remote control, and then we are taking from the 2 timers with input capture setup, we're capturing the value, and for that we need to check the analyzer if the signal comes from transmitter to the receiver and actually to the MCU to use it for the balancing and steering the drone. Okay, so let's, yeah, it is connected. We can load firmware. And currently it will stop at bridge calibration. Okay, and I will stop here as well. Okay, it wasn't going there, so also let's currently start analyzing. So first channel is a low signal, so I will, let me check, I will power up. Okay, and now we need to see that there is orange signal from the okay, I'm not sure, maybe you see the orange diode there. So it's binded currently. So with the procedure that sticks to the down to the center. Okay, I will run it, and you see that, okay, so it's ARM currently, and you can see that the lowest signal is 1 millisecond. So for the DSM2 spectrum, DSMX, the frame is 22 milliseconds, and the lowest is so in microseconds it's 1112. Okay, so this is the lowest signal. And if I will, because I'm saying about the throttle, so this is the throttle, so we will go, it's wider, and the maximum is 1943 microseconds, or 1,943 milliseconds. Okay, and I can close logic application. We see that for pitch, roll, and yaw, and those channels you can see in the RC control. So there are, okay, so we are there. So it's the middle is 1530 microseconds width of the signal, and I'm not sure which one is it. It's yaw. Okay, so lowest is 1114, so it's between in that range, and maximum is almost 2000. So yeah, so this is how it was decoded. And if I actually stop application, because we are sending the commands also to the motors, so I will disconnect in the reverse side. So the hub, okay, hub is disconnected, and I will disconnect also the main power, and I will stop using that, and that was with one break of 1. Okay, and currently let's run it again, and actually to ARM motors, and okay, so for that we don't need to use, I will take out the logic analyzer. Oops. Okay, that one as well. Many cables, many wires. Too much. Okay. And what now? So reverse side. So we need to power up drone. Then we can power up ST-Link. Okay, it's also just one left. Okay, computer is still there. ST-Link version. Okay, but now it's the ST-Link. Okay. All right. So let's run again. Okay. And what we have as well, flight no, that's main, flight control, bridge set motors, okay. So it's almost same what is in the GitHub. Okay, but the name for the radio map. Motor commands. What is the name for the motor? So it will be motors. Okay, it comes from motor 0. Okay, where we are. Okay. Let me find motor information. Is it in the bridge? I'm in sequence. Motor commands. Okay. Yeah, so the range is it is one shot 84, so 42 to 84, but because we are using 150 megahertz, so we need to add half. So from for 2000 for 420 we need to add 21, so it has 63, and same with the 840. So okay, all are running. And 2 clockwise, 2 counterclockwise. Yeah, so now flight controller algorithm. Okay, we can stop and we can start again. Okay, they are working. Cheers.